How do you refer to specific individuals on a basketball team? On their jerseys, they have their names and their numbers. In a similar way, compounds can be identified by either their names or their chemical formula. Hi, and welcome back. In today's science episode, I will talk about writing formulas and naming compounds. Writing formulas and naming compounds. And in this video, I will concentrate in binary ionic compounds. Oxidation numbers. To write a chemical formula, you need to know the elements involved and the number of electrons they gain, lose, or share to become stable. This last piece of information is what chemists refer to as an element's oxidation number. An oxidation number is a positive or negative number that indicates how many electrons an atom has gained, lost, or shared to become stable. Now, maybe you're asking, how can I know the oxidation number of an element? Well, using this. The number at the top of each column is the most common oxidation number of the elements in that group. So, for example, this group has an oxidation number of 1, and it means that it's positive. This will have 2 positive, 3 positive, 4 positive. Now, these ones have a 3, but is negative. 2 negative, 1 negative, and 0. Now, you might be asking, and what happened with the transition elements? Many of the transition elements can have more than one oxidation number, as shown in Table 2. When naming these compounds, the oxidation number is expressed in the name with a Roman numeral. For example, the oxidation number of iron in iron third oxide is 3+. Binary ionic compounds. The easiest compounds to write formulas for are binary compounds, which are composed of 2 elements. When writing formulas, remember that although the individual ions that make up ionic compounds carry charge, the compound itself is neutral. And this is an important fact that you're going to see how we apply this information in the examples. For example, lithium fluoride is composed of a lithium ion. So let's find lithium in the periodic table. It's right here. And as you can see, it has an ion of 1+. Now, fluoride ion. Let's find fluoride in the periodic table. It's right here. And as you can see, it has a -1 charge. One of each ion put together makes a neutral compound. So what you do is like a mathematical equation. You use 1 minus 1 equals 0. So that means it's neutral. So my formula will be LiF, or I use the symbol for each element, lithium fluoride. Some compounds require more figuring. Let's do an example. Aluminium oxide. First, what 2 elements make this compound? Aluminium oxide. Think about it. It's made of aluminium and oxygen. Now, let's use the periodic table. Let's find the ions for each element. Aluminium is right here, so it has a 3 positive. Oxygen is right here, and it has a 2 negative. Like this. Now, if we add this, we'll have an equation like 3 minus 2, right? Because the 2 is negative. 3 minus 2 equals 1. In this case, the 1 will be positive. So that means it's not neutral. So maybe you can think, okay, we have less oxygen. Let's add another molecule of oxygen. Good. Now I will have 3 for aluminium, and for oxygen the total would be 4. So this will be 3 minus 4 will be minus 1. Still not neutral. So now you think, well, we have more ions for oxygen, so let's add another aluminium. So now, in this case, we have 6 ions for aluminium. We have 2 molecules of aluminium and 6 ions. And for oxygen, we have 2 molecules of oxygen and a total of 4 ions. So it will be 6 minus 4 equals 2. Still not neutral, but be patient, we're almost there. So now you can think, well, we still have less oxygen. So let's add another molecule of oxygen. Okay, so for aluminium, I have 6 ions. And for oxygen, I have 3 molecules and a total of 6 ions. So that would be 6 minus 6 equals 0. So now it's balanced. Now let's write the formula. How many aluminium molecules we have? 2. How many oxygen molecules we have? 3. So now we use the symbols. The symbol for aluminium and the subscript 2, because it means we have 2 molecules of aluminium. Then the symbol for oxygen, the letter O, capitalized, and how many molecules we have? 3. So this is my formula for aluminium oxide. Now, there is an easiest way to do this, and is by finding the least common multiple of 3 and 2. Remember, the aluminium have a 3 plus ion and oxygen a 2 negative. So what is the least common multiple of the number 3 and the number 2? Think about it. If your answer is 6, you are correct. So 6 divided by 3 is 2. And 6 divided by 2 is 3. So I know that I have 2 aluminium molecules and 3 oxygen molecules. And there I have the aluminium oxide formula. So you can choose the method that you find easier. So for writing formulas, as a review, once you have found the oxidation numbers and balance them, you can write formulas for binary ionic compounds by using the rules below. Write the symbol of the element that has a positive oxidation number or charge. All metals have positive oxidation numbers. Hydrogen often does. 2. Write the symbol of the element with a negative oxidation number. No metals have negative oxidation numbers. Hydrogen does occasionally when bound to a metal. Find the least common multiple of the charge of each ion. The charge without the sign of one ion becomes the subscript of the other ion. Reduce the subscripts to the smallest whole numbers that retain the ratio of the ions. Now, naming binary ionic compounds, we're going to use the following rules to give them the names. Write the name of the positive ion. Number 2, using table 2, this one we have here, check to see whether the positive ions form more than one oxidation number. If so, determine the oxidation number of the ion from the formula of the compound. Remember, the overall charge of the compound is 0, and the negative ion has only one possible charge. Write the charge of the positive ion using Roman numerals in parentheses after the ion's name. Write the root name of the anion. The root is the first part of the element's name. Chlorine is chlor, oxygen is ox. Then add the ending IDE to the root, as shown in table 3. So oxygen will be oxide, phosphorus will be phosphide, nitrogen will be nitride, sulfur, sulfide. And subscripts are not part of the name for ionic compounds. So the first element is called the cation because it's a positive ion, and it's just the element name. The second element is the anion. It has a negative element. And use the element name with IDE ending. Now, there's a lot of rules, but it's easier to understand all these rules by practicing. So I have an example for you. Name a binary ionic compound. What would a chemist name the compound CuCl? So, Cu, this symbol stands for copper, and Cl stands for chlorine. Now, the first rule, this says that the first element has a positive ion. So I just need to write the element's name. In this case is copper. The second element is my anion, is a negative element. Chlorine is negative. So I need to add the IDE ending, okay? So what is the root of the word chlorine? Oh, all those spelling classes that you have received before is chlor, right? Until here, CHLOR, chlor. And then I'm gonna take out this part and add IDE. So it's gonna become chloride. Copper chloride is the name for this binary ionic compound. I hope you found this video useful. Thanks for watching, and until the next one, bye!